Okay, let's find the domain of a few functions here. Um, yeah, so there's the domain refers to the values of x that you're allowed to plug in. And what do I mean by allowed? There's certain things that you're not allowed to do. You're not allowed to divide by zero. You're not allowed to do the square root of a negative. And by the way, we don't really talk about complex numbers in this class. So as far as we're concerned, you're just not allowed to do the square root of a negative number. Um, and then there's a few other things, like you can't do the logarithm of a negative number, but we'll get to that. So on this one, we do have division. I see a fraction, so we had better make sure we're never dividing by zero. Whoops. Um, so other than that, we don't really have any problems. Sine and cosine don't have any domain restrictions. You can do the sine of whatever number you want, and you can do the cosine of whatever number you want. Really, the only danger here is that we would ever be dividing by zero. But actually, if we think about it, we aren't ever dividing by zero. Here's how I know. Sine and cosine, I guess right now I care about cosine, they're always between -1 and 1. So this denominator, it's 2 plus cosine. If I just add 2 to everything, I get 1 less than or equal to 2 plus cosine less than or equal to 3. So this number that we're dividing by is always between 1 and 3. It can't be 0. So for my answer for this one, I'm just going to say the domain is all real numbers. I can plug in any value of x that I want. I was a little bit worried that I would ever be dividing by 0, but then I convinced myself that that doesn't happen. So all real numbers are fine. Let's talk about the next one. The next one, of course, is very similar. It's just that I changed this 2 into a 1. And of course, now we do have a potential problem, because cosine can really be -1. Like I said that it's always in between -1 and 1. Sometimes it is exactly -1, and if that's the case, we're going to have a problem. We're going to get 0 in the bottom. We're dividing by 0 if cosine x is -1. So now it's like, now we just have to solve this equation, cosine x equals -1. So it helps here if you have a little knowledge of the cosine function. Let me draw a rough graph of this. Right. So here's 1, here's -1. The graph starts here. Cosine of 0 is 1, so this is the point 0, 1. And this is like the high point, and it has a period of 2 pi, right? So after 2 pi, it's going to be at its high point again. And in between here and here, it just has this sort of familiar looking sine or cosine curve. Like it goes down, it hits its low point, comes back up. Yeah, I'm not a great artist, so I'll just make the dot bigger. But it looks something like that. And by the way, the low point here is, of course, -1. And by the way, that's what we're really interested in. We're interested in when this graph is -1. And that's the low point. The low point occurs exactly halfway in between the two high points. So if this is 0 and this is 2 pi, then this is pi. So when x equals pi, that's an example of a value of x where cosine would be -1, and then if we were to plug that value in here, we would be dividing by 0, and that would not be in the domain. However, because this is a periodic function, there are more values of x. Like, basically every time this hits a low point, and I don't want to mess up my picture too bad here, but if I were to keep drawing, it would hit another low point at 3 pi, because the period is 2 pi, so every time I add 2 pi, it's like we're back to the same point again. So what is not in the domain is x equals pi, and also if I add 2 pi or another 2 pi, like I would also have a problem at 5 pi. What I'm saying is, if I add any multiple of 2 pi, that's also a problem. Whoops, the video went blurry. So pi is a problem, 3 pi, 5 pi, 7 pi. Also, this includes negative numbers. Like, I could do pi minus 2 pi, and that would give me negative pi. So negative pi is also not in the domain, -3 pi, -5 pi. You could say all odd multiples of pi. So anyway, let me state my answer here. So the question was, what is in the domain? And I've given you what is not in the domain. The domain is all real numbers except okay. Now let me talk about a couple other ones, and these are basically easier. Part B is the hard one out of all of this. I just wanted to remind you about square roots and logs. And I sort of stated the rule here just a second ago, but to do a square root function, you just can't do the square root of a negative. So in order to do the square root of this thing, it needs to be greater than or equal to 0. And I can solve this. X is greater than or equal to 2/3. So the domain is all real numbers x as long as they're greater than or equal to 2/3. Okay, and let's do logarithms. For logarithms, it's almost the same as square roots. To do the square root of something, it has to be greater than or equal to 0. To do the logarithm, it has to be just greater than 0. And then that's the difference between square roots and logs, well, at least in terms of domains. You can do the square root of 0. The square root of 0 is just 0. The square root of 0 isn't a problem, it's not an error, it's not undefined. The square root of 0 is just 0. You cannot do the logarithm of 0. The logarithm of 0 is undefined. To do the logarithm of something, it has to be actually greater than 0. It cannot be 0. So, but it's a small difference. So what do I do here? Instead of setting this greater than or equal to 0, it's just greater than 0. And then this is easy. I would subtract the 1 and divide by 5, so x is greater than -1/5. So the domain is all real numbers x such that x is greater than or equal to -1/5. Okay, so yeah, that's all I had for right now, so this will be a little bit of a shorter video. Yeah.